Understand what a mass spectrum of an element represents. In a mass spectrum of a pure element, the peaks along the horizontal axis, representing mass-to-charge ratio, m/z, which simplifies to mass in AMU for singly charged ions, correspond directly to the individual isotopes of that element. The height of each peak along the vertical axis represents the relative abundance of each isotope in nature. Read the isotopic masses and their approximate relative abundances from the graph. Isotope 1. Mass approximately 90 AMU, relative abundance approximately 51%, slightly above the 50% grid line. Isotope 2. Mass approximately 91 AMU, relative abundance approximately 11%. Isotope 3. Mass approximately 92 AMU, relative abundance approximately 17%. Isotope 4. Mass approximately 94 AMU, relative abundance approximately 17%. Isotope 5. Mass approximately 96 AMU, relative abundance approximately 4%. Recall how the average atomic mass of an element is determined. The average atomic mass of an element reported on the periodic table is a weighted average of the masses of all its naturally occurring isotopes. Average atomic mass equals sum, fractional abundance times isotopic mass. Estimate the weighted average based on the peak distribution. Since the isotope at 90 AMU is the most abundant, approximately 51%, the average atomic mass must be heavily weighted toward 90. However, because nearly half of the atoms in the sample, approximately 49%, are heavier than 90 AMU, with masses of 91, 92, 94, and 96, these heavier isotopes will pull the weighted average above 90. Since the mass 90 isotope represents more than half of the total abundance, and the rest of the isotopes are relatively close to it in mass, this weighted average is mathematically prevented from reaching or exceeding 92. Average atomic mass approximately 0.51 times 90 plus 0.11 times 91 plus 0.17 times 92 plus 0.17 times 94 plus 0.04 times 96. Average atomic mass approximately 45.9 plus 10.0 plus 15.6 plus 16.0 plus 3.8 approximately 91.3 AMU. Note: this element is zirconium, Zr, which has an actual atomic mass of 91.22 AMU. Select the matching option because the average atomic mass is approximately 91.3 AMU. It falls between 90 and 92, verifying option D as the correct answer. The correct answer is option D. The atomic mass of X is between 90 and 92.